Okay. So now we have our kind of our one-offs. Kind of one-offs. We've got Git here that I haven't really thought out, and honestly, Git's probably going to be very similar to everything else, because we're going to have Get and then target. So really, our only one-off is going to be if the command trim and toLowered is equal to look. It's just look. That's our special case. So let's go ahead and take that and put it here. So kind of our special case is if they just want to look at the room, and we're just going to handle that and exit. And our little else thing here, which is we're handling that with the, so let me scroll down, sorry for all the fast scrolling, with a no shootable command. So we can go ahead and get rid of that as well. Alright, so Grunes says, why not have a command metadata map instead of just game action? This metadata would hold the game action and also see if it takes parameters, and if so, how to handle them. So, the idea is, why not have fight be mapped to some more complex object, right? It's a little bit more difficult to show that example, so hopefully it'll be clear just by talking about it. So the idea being that I can encapsulate all the things that fight needs to do in another object, and then I can just pass an argument. This is actually a really good idea when you start getting into some more event-based programming, and I do it sometimes with delegates and actions, and then I'll dynamically invoke those delegates, passing in the arguments at runtime, and it does add a layer to the application. It does add a little bit of flexibility. The only reason why I'm not doing that here is because I think it shoots out past what we've done so far in our design patterns. But if you're curious about that approach, and you come over to GitHub, my GitHub anyway, and you click on Sharpbox. Sharpbox is an application of Flex architecture, and it uses command query separation and also the event sourcing design pattern. And close your eyes and shut your ears if you're not quite ready to digest this kind of stuff. But there's going to be a console application with all of the examples, and there's quite a few. But this application does what Gruens, and correct me if I'm saying that wrong, kind of suggested, which is inside of my dispatcher, there's a lot of queues, dictionaries, so you kind of see this command hub item. This is going to be the example since it's been encapsulated in the way that Gruens describes. So you can see that stuff here, and you can also see the complexity that goes into it. So great idea. It's already been implemented here. You can check out that project for that. But for Mudsy, for right now, before we get into all that, is just trying to keep it a little simple. So don't look at the way we're doing this as the way it will end up or the way that it absolutely should be done. Instead, look at this as we've got an immediate code smell, right? Something in our code is presenting redundancy, technical debt, so it's becoming hard to manage. We've got the same code repeated. And in this moment, within the scope of the application, we want to just try to find a better way to handle that. And also in ways that we know, like, so based off the last 7 weeks of kind of learning. Okay, so I'm just going to add on here get. game actions dot. I don't actually have a get yet, so we're going to go to our enum and do a get. Come back over to our command parser, and so we're going to map the word get to the action get. And by doing that, we can get rid of whatever this is. It's not implemented, but we're deferring the throwing of this to something else. So whatever this gets to, right? So this is going to go to the hive mind and say, hey, or not, it's going to say, hey, give me execute get. And then it's going to come here, and it's going to fall through, not fall through, but it's going to get through its case statement, and it's going to get to here and throw not implemented exception. So by us throwing the not implemented exception, it wasn't wrong, but it was kind of redundant. So this is kind of like a functional programming approach. And more on the reason why we're not doing the null checks and all of that. Because we want our application to surface whatever exceptions arise naturally, and then have the calling layer handle them, because it's set up to do so. When you've got every tier of your application handling exceptions differently, you're going to lose your stack information. So you have to be very careful with how you throw it, how you catch it, and how you propagate it. This is just one approach for doing that, and it's the simplest. We're just saying, okay, we don't have to worry about any of that or get too deep in right now. So let's just have everything fail. If it's going to fail, it fails, and then we'll have the last bastion, right? The hive mind handle all that. We'll just say, hey, I'm going to throw it down the well, and then whatever happens, happens. If it fails, I'll let you know. Does that make sense? I don't know if I might get lost in my own words there for a second. Okay, so we no longer care about throwing the not implemented exception. We're going to let the application do that. Okay. So, what this allows us to do, because we're in the CLI and we're letting HiveMind handle the not implemented exception for get, we no longer care about it. But because we're at the presentation tier, we're at that last batch, we're at that last step, we now just want to wrap all this in one try-catch block. And we want to take all that and throw that in there. And then we can decide how to handle that exception. So, just to kind of recap. Well, let's take this and we'll put it down here. Okay, so if we look at what we had before, and I'll do that just by jumping over to GitHub, and I'll look inside of our CLI and our game engine and our command parser, and I'll put that there, and I'll put this guy over here, and I'll get rid of that. Okay, so this is our new execute command. We're getting in our response, oh no, so we're getting in all our parameters, we're throwing it through our little grinder, and we're catching any exceptions that happen, and then we're going to output whatever response we have at the end of all this to the console. Previously, we had all of these if statements and all this kind of duplicate code. That's what we're doing before versus what we're doing now, and so it would have been very unclear if we had wrapped all this in a try block, what we were actually trying to catch. We wouldn't know. Or to say it would be a lot of noise. I think it's, at a glance, it's hard. If you can't see the end of your try block on, like, above the fold, I think it's difficult to kind of keep that that at-a-glance context of what's happening. Kind of one of those little heuristic points that's a lot like, hey, if your class file is longer than 300 lines of code, consider splitting that up somehow, because you're a human being, and by the time you get to line 464, you don't have a contextual understanding of what happened at line 30. So hopefully this does a few things, this refactoring. It allows us to be more concise and more expressive in our code and our intentions. It also allows us to handle error checks more gracefully. It also allows us to expand out the application when the time comes more easily. So instead of having to copy a new block of this and redo it, all we have to do now to get that same effect is add it to the map. We add get to the map, and we can automatically handle a new type of command, right? As opposed to, well, if we want to handle a new type of command, we've got to copy all this code over. It's very brittle. We're just changing small details and hoping that it works. This is much more solid. And then we're letting the hive mind, like if it bombs out, we're going to catch it here. If anything happens in the game engine that says what you gave me was nonsense, we can handle that in our exception. And so let's go ahead and write a method that's going to help us do that. Scrolling down. We already have a no suitable command that handles when we can't find a command. What if we... Oh, sorry, hang on. We're just going to do exception response. We'll just pass in the player for now. We're going to do something very similar to this. Alright, whoops, something went hella wrong, please try again. This is what we want for the exception message, or exception response. Cool? Cool. Oh, we need this to be an else. So we're saying that our edge case is look, just looking around the room. And if it's not that edge case, that one look command, then go ahead and just process the get game response method. If anything here goes crazy and dies, then go ahead and process the exception game response. And then once we have a response through false, error, or happenstance, we're going to go ahead and clear the previous line, display the command, and draw the status bar. So I think this is actually like what I was saying before, where we're starting to get to a point of complexity where like we're in the weeds, and it's good stuff. It's really good stuff because you always want to know like how, when, and why to refactor things, and if the level of effort you put in is going to be worth it. So here I think it is. It looks really nice, but people will convince you they write this way the first time. Like they just sit down on a computer and they write these brilliant algorithms, and they write this brilliantly like factored code. Those people are liars. Don't call them out. Be diplomatic, but those people are not telling you the truth. I consider myself to be a really decent programmer, and I start with a very simple approach, and then I look at it, and I stare at it, I go to the back.